Today I'm going to be talking about the history of calculus. Here's a summary of what I'm going to do. The history of calculus, how calculus is used, why we need to learn calculus, and how it is helping us today. Who invented calculus? Infinitesimal calculus was developed in the 17th century by Isaac Newton and I'm not really sure how to pronounce his name, but whatever. Egyptians used calculus also to calculate the volume and area of certain objects. Isaac Newton and Gottfeld actually developed calculus separately from each other, which is actually pretty cool. Elements of calculus appear in ancient Greece, China, and in the Middle East. How calculus is used. Calculus is used in many different ways. It's used in physical science, the study of the inorganic world, not living things. Actuarial science, the qualification of risk using math. Computer science, the study of using computers. Statistics, the science concerned with developing and studying methods for collecting. Engineering, the branch of science and technology concerned with the design, building, and use of engines, machines, and structures. Economics, the study of scarcity and its implications for the use of resources, production of goods and services, growth of production, and welfare over time, and a great variety of other complex issues and vital concern to society. It's used in many other things as well. Why we need to learn calculus. As shown in the last two slides, calculus is used in many ways to help society progress in its goals. Calculus was used to help with the space travel and things like that. It is also used in business and economics, which are very important in today's society. Another reason for learning calculus is that it is used in so many sciences, helping in any number of problems. How calculus is helping today. Structural engineering is one of the most critical applications in real life. One of the most critical applications in calculus in real life is structural engineering. Calculus is used to calculate heat loss in buildings, forces in complex structural configuration, and structural analysis in seismic design and requirements. Civil engineering. When designing bridges, civil engineers need to consider three structural elements: beams, tension, and comparison members. Using calculus, we can determine the amount of force acting on the beam, including the weight of pedestrians, weight of vehicles, and the amount of traffic anticipated on that bridge. Based on these factors, the material's size and capacity can be computed. In electrical engineering, integral and differential calculus are crucial for calculating voltage and current through a capacitor. Integral calculus is also a main consideration in calculus. The exact length of power cable necessary for connecting substations that are miles apart from each other. Mechanical engineering. Mechanical engineering is yet another great example. The pump used for filling an overhead tank, gardening tools, cars, motorcycles, robots, and many household appliances are designed using the principles of calculus. It's also used in spaceflight engineering. Before launching a rocket or exploratory probe, engineers must use calculus to figure out the gravitational pulls of the sun, the moon, in order to know how to launch a probe or hit the velocity needed to orbit the Earth. It's also used in medicine. Calculus is used to determine the growth or shrinkage of a number of cells of a cancerous tumor. Using exponential functions, oncologists analyze the progression or regression of a disease. In conclusion, calculus was created in the 1700s by Isaac Newton and that other guy. It is used in many different ways to help around the world. There is many different reasons we should know calculus, as I've shown in this presentation. Calculus is helping us in the engineering field, which is the field I'm planning to go in, and calculus also helps us in the uses of medicine, including cancer.